Good morning, students. So in today's video I'll start a new chapter, number system. This is from the same unit, computer fundamentals. So this is chapter number 4. This is after the operating system. So let's look at the contents. So today we'll discuss the following topics. What is number system? So definition of number system, the different types of number systems that are used. So what is radix or base? What is weight? What is MST and LST? Okay, and then MSP and LSP. So in the introduction part, okay, data in a computer is stored in the form of binary digit, which is 0 and 1. So in the first chapter you have seen that how computer stores the data format, right? So it is in the form of binary, which is bit, which is 0 and 1. So 0 means off and 1 means on. It is same like switching on and off your light switch. If you press down, that is on, the light bulb glows, and if you press up, that is off, so you switch off the light. So same like that. Okay, the binary digit also 0 and 1, it works like on and off only. So that is the easiest way through which the computer can understand. So 1 0 or 1 1, it equals to 1 bit. So if you have 0 and 1, that is you have 2 bit. Okay, so in number system, okay, in terms of binary digits, okay, in terms of binary digits, a single 0 or a single 1, a single 0 or single 1 is called as a bit. Then if you have 4 bits of zeros and ones, like 0101, that is called as a nipple. And if you have 8 bits, that is a combination of zeros and ones, 8 in all total, it is called as a byte. And if you have 16 bits, 16 numbers of zeros and ones, then it is called as a word. Okay, so characters like A are converted. So you have in your keyboard, you have lots of symbols other than numbers from ranging from 0 to 9, and you have semicolon, you have comma, you have the alphabets A, small letter A, like that. So these are converted to numbers. Okay, so integer values, these are converted to integer numbers, which becomes easier to convert into binary equivalent for the computer. Okay, so you can see that the numbers that all the numbers that are formed, it is formed comprised of only 10 digits. So based on these 10 digits, we can form different numbers, right? So now we'll discuss about the definition and types of number system. So what is a number system? In short, number system is a way of representing the computer data through numbers. So all the data that are entered in the computer, these data, how are they represented as numbers? Okay, and even the characters. Like that. So we have the different types of number system. We shall see one by one all of this, okay, in different slides. So we have decimal number system, binary number system, octal number system, and hexadecimal number system. So the first one is the decimal number system. So in decimal number system, 10 digits are used. That is namely 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so all of this is used in the decimal number system. So since 10 digits are used, so the base or radix of this decimal number system is 10. That is representing from 0 to 9, 10 in all, right? So in decimal number system, okay, we use for the base as den. Okay. So the value of the digit in decimal number system, it can be determined by the position place of the digit in the number, that is by the power of 10. Okay. So when you talk about the value of the digit, like for example, if you see there 187, right? 187, so we call it 187, right? So in here the numbers are placed in decimal number system. Okay, the numbers, the place value of the numbers are placed by the order of units, tens, hundreds, thousands. So this also determines the weight of each digit. Okay, that is the place value of each digit. So in here, like as it's written, the value of the digit can be determined by the position place of the digit in the number, that is by the power of 10. So here 187, this is a decimal number. Okay, this is an integer number, this is an integer number. Okay, so in number system, okay, this becomes a decimal number. So when it in the expanded notation format, okay, 187 can be written in this format. Okay, 1 into 10 raised to the power 2 plus 8 into 10 to the power 1 plus 7 into 10 to the power 0. Okay, so 10 to the power 2, okay, that is when you expand it, it becomes 100. 10 to the power 1 is 10, and 10 to the power 0 is 1. So 10 to the power 0 is the units place, 10 to the power 1 is the tens place, 10 to the power 2 is the hundreds place. So the the weight of each digit is determined by that place value. So like example 7, 7 is in the units place, 8 is in the tens place, 1 is in the hundreds place, right? So by that we find out the value of each digit, like 1, 1 is one digit, 8 is another digit, 7 is another digit. So 7, the weight of the 7 is placed in the units place, 8 is placed in the tens place, and 1 is placed in the hundreds place. Okay, so I hope that you have understood. Okay, so by that we can determine the weight of each digit. So weight of 1 is determined by the power of 10 to the power 2, that is 100, right? In the same case, 8 is determined by the in the tens place, like that. So 8 into 10 is equivalent to 80, like that. And 1 into 10 to the power 2, which is equivalent to 1 into 100, is 100. And the same case, 7 into 10 to the power 0 is 1. So 7 into 1 is 1. Okay. So according to that, we have what is called as most significant digit, MSD, and least significant digit, LSD. So what is MSD? So MSD is the digit to the far left of the number which holds the maximum value. So this MSD, most significant digit, that particular digit 1, it holds the maximum value. That is, in terms, in this particular example, this holds the value 100. And LSD, least significant digit, is the digit to the far right of the number which represents the least value, that is the least place value, that is in terms of 7 into 1, it is 7. Okay, so I hope that you have understood from this the decimal number systems. Okay, next we have is the binary number system. So binary number system use only two digits. We already know about that, right? So 0 and 1, that is 1 0 or 1 1 represents 1 bit. So since there are only two digits, so the base is 2. Okay, so the base is 2. Now numbers in binary number system, since the base is 2, okay, so 2 will be used 2 will be used as the base to determine the place value, and 2 to the power exponential will be used to determine the weight. So in here, the binary number 1101. Okay, so you can read it as 1101. That is the binary number. So it will be written as 1101 in this format, 1101 to the base 2. Okay, and in decimal number, okay, with the decimal equivalent of 1101 is 13, so it will be written as 13 to the base 10. Okay, so in binary number it is 1101, but in decimal number, that is in integer format, okay, it is 13. So what happened is that, okay, the computer, okay, the computer understands the decimal notation, and then which converts it into binary format, that is 1101. Okay, because it is easier to convert in from integer format to binary format, like that. So every character that you type, suppose A, B, C, is first converted into the decimal format. After that, it's convert to the translated into the binary format, like that. So now the positional weight or place value of the binary number, okay, this is shown below. So this is the weight. So in the weight section, you can see that starting from the rightmost, okay, to the power 0, here in place of 10, 10 is, since 10 is used for decimal because you have 10 digits. In the case of binary, you have only 2 digits. That's why we use the number 2. Okay, so here 2 to the power 0, which is 1, and 2 to the power 1, the real value of that is, when you multiply, it becomes 2, and 2 to the power of 2 is 4, to the power of 3 is 8, okay, 2 to the power of 4 is 16, and so on. So this will keep on going like that. So here also we have what is called as most significant bit and least significant bit. So here most significant bit is the leftmost binary digit of highest binary weight. So the leftmost uh, digit is the most significant bit, and it contains the highest binary weight. And the least significant bit is the rightmost binary digit, which contains the lowest weight. Okay, so for today, uh, I hope that you have understood the decimal number system and binary number system. Okay, in the next video, I'll be discussing more about the octal hexadecimal. Okay, then the number table conversion, and also the conversion from binary to decimal, decimal to binary, and so on. Okay, so that will be all for today's